Going the other way is a little bit harder, but not a lot. So here's an equation in general form, all the terms equal to 0. When you get used to it, you can recognise this as the equation of a circle. Actually, it could be one of a few other things as well, different conic sections, depending on this number here. But for the moment, you can just assume anything you see like this is going to be a circle. So, assuming it's a circle, I should be able to write it in the normal Cartesian way. X minus something squared, y minus something squared equals radius squared. To get there, I have to complete the square. If it's been a while since you did completing the square, or if you haven't done completing the square, go watch my other videos first on completing the square, because this might otherwise look like magic. Let me show you. I want x squared plus 6x to turn into x plus something squared. And to get there, I have to go back to the rule we know, x plus 2ab plus b squared. So this term, the 6x, has to be 2 times a times b. Well, it's 2 times 3 times x. So let's write it like that. X, I don't know why I put the bracket there, I don't need that yet. X squared plus 2 times 3 times x plus something. Now the something is something squared. It's this. This x squares to x squared. This 3 has to square into 3 squared. So x is a squared plus 2 times a times b plus b squared. Okay, there is a problem before I go on, and that problem is I've just added 9 to the left-hand side. I don't want to keep that 9 there. Way over here, I'm going to write minus 3 squared. And I'm going to do it straight away so I don't forget about it later. All right, let's complete the square for y. Y squared, a squared, minus, in this case, 2 times a times b. It's got to be 4. It's half of this. And then I'm going to add b squared. Now I've just added 16, so I'm going to subtract that 16 over here. Don't forget, we've still got to subtract 5. Now, why did I do that? Because it means I can write this whole section here as x plus 3 squared. And I can write this whole section here as y minus 4 all squared. And that's what completing the square is about. Rewrite this by adding something to make it a perfect square. Just don't forget to subtract it as well. Over here I have minus 5 minus 9 minus 16. So this is, actually this way is easier. 9 and 16 is 25, plus 5 is 30. And our usual Cartesian form puts that on the right-hand side. So we're going to go equals 30. So I've completed the square twice in order to rewrite my equation from general form into Cartesian form. So now I can tell you that this up here, my original equation, is the equation of a circle centred at -3, +4, with radius √30. Let's try another one. So here's the equation of a circle in general form. Something equals 0. I look at it and I recognise it. This looks like it might be a circle. Let's try it. Complete the square. X squared minus 5x is 2 times 2.5. So it's 2 times 5 on 2 times x. And then I'm going to add 5 on 2 squared. That's my dog barking at the neighbour. Now before I forget, let's go over here and subtract 5 on 2 squared. Okay, let's complete the square for y. Y squared minus 2 times 2y plus the 2 squared. And subtract the 2 squared before I forget. Plus 3 equals 0. This becomes x minus 5 on 2 all squared. This becomes y minus 2 all squared. Now I have plus 3 minus, now this is funny, this is 25 on 4 minus 4. 3 take 4 is negative 1. Let me do that. I was going to move them to the right hand side. Now let's leave them where they are. That's negative 1 minus 25 on 4. Now this, 25 on 4 and another 4 makes 29 on 4. I'm going to put it on the other side. (29 on 4). So, this original equation is indeed a circle. Centre is 2.5, 2, and the radius is root 29 on 2, or the square root of this whole thing. Now, a tricky question. If instead of 3 here, I had, let's say, 23, what would this eventual equation have been, and could it have still been a circle?